Hey guys, it's John, Sub-Zero Gaming. Today is going to be tutorial 2 of the new 2D platformer we're going to create. Today we're going to do the 2D character controller. Before I continue, I just want to quickly go over what we did last time with the character sprites, because I'm actually going to use a different sprite sheet. And I recommend you do this as well if you'd like to have a jump animation. I got a new sprite sheet that looks like this. And this is the one you can also get on Google. Just type in Tim Braid sprite sheet and this is all of them. I'm only using the idle and run ones, but I'm also including the jump this time. I don't really care about the climbing ones or the out of breath ones. It's just so that I can have my character jump. So if you want to, you can skip about maybe 4 or 5 minutes into the video, or you can watch me go ahead and cut this and create the animations for it. So basically what I'm going to do is go and import that sprite. I'm just going to name it Tim. Alright, and remember, go to sprite mode, multiple, go to sprite editor, and this is going to be an easy one to slice. Just go to slice, automatic, and this one did a very good job at cutting them all. There's only one that missed, and I'm not even using this animation. Actually, that might be the jump one right there. So I'm just going to go ahead and put a box around it. Alrighty. Trim it down. Alright, and hit apply. Done there. And I also want to show you this. I didn't mention this last video. If the texture, for whatever reason, do you see how it's a little blurry in that bottom right corner? If for whatever reason it's blurry like that, you can actually fix the quality. You can change it. Go to the main texture, and you see here where it says max file size. Make it 4096 and format true colors. And I believe this only works on PNG images, or PSD for that matter. So what you can do is, now check them out. Much more clear and a more crisp image. So it just looks a lot better. So here we go. So what I'm going to do is I'm just going to put Tim in there, and I can't see him, and we all know why, because it's not on the foreground layer. Now he is. There's Tim in there. See him in the game view. I'm just going to scale him up by 2. Alrighty, good stuff. Alright, so here's Tim, and now I need to recreate his animation. So I click on Tim, go to the animation tab, record. This one's going to be idle. I'm going to put it in my animations folder. Alright, now I just need to get all the idle animations, which should be 0 through 11, I believe. Nope. Okay, 0 through 21. Just going to go and drag them in there, test it out. It's like hyperventilating. I don't like that. So I'm going to go and make it like maybe 12. Alright, 12 looks really good. So I'm going to go ahead and stop it, save it. Just hit the record button to save. Alright, his animation for Tim is created, and an animator component automatically got attached. Make sure apply root motion is unchecked. If it is checked, during the game, something weird with gravity happens and Tim will start to float up. So make sure you always have apply root motion unchecked. Alright, let's go and do the run animation next. Go to this idle, create new clip. Let's name this run. Save it in your animations folder. And let's go and look at the running ones. So 21, so it should be 24. And this one's actually split up into multiple, so it's looks like it's 24 through 32. Go and drag that in there. And then we're not finished yet. There's more of them down here. Alright, looks like it's 42 through 50. Looks like it goes by 8, so 42 through 50. Just going to drag that in there as well. Make it consistent with the others. And then we're still not done. I believe there's more. Yeah, there is. Alright, 60 through 68. Those all look good. Alright, let's see if that was the last one. Alright, good stuff. Let's go and test it out. Alright, good. It's running nicely. It's a little too fast though. Make it like 32. Alright, I'm happy with 32. We can keep that. Alright, good. So now we have that one created. Click your animator. We have idle and we have run. Now I'm going to go ahead and do the jump animation. Let's see here. So click on player, run, create new clip. It's going to be jump. Alright, let's go and record this animation. For jumping, what is it? Let's see here. Alright, that looks like kind of like the fall. Actually, not sure what that one was. Let's see here. I'm going to use this one for the jump. So 97 through 111. Looks like a jump to me. And then let's see if there's any more. That's him doing. Alright, it looks like 128 through 137. Could be part of it. And see if there's any more. Alright, and that seems to be it. So let's go and test this animation out. How does it look? Alright, definitely way too fast. Make it like 32. Too fast. Let's try 12. 16. Alright, we'll give that one a go. 16 looks good for me. Alright, these also might not be the right jump animations necessarily, but it's the best I could do. Okay, cool. So in the beginning of this video, I would say skip ahead to 7 minutes if you'd like to skip what we just did here. So now that we have all of our animations created for Tim, now what we can do is talk about the character controller. So basically what we would need to do is we're going to have him moving left and right, and then we're going to have him jump. And the logic for jumping is, when can you jump? You have to be grounded, right? So we have to create a system to check for how we are grounded. And we're going to dive into 2D physics raycasting, and I think you're really going to enjoy that because there's a lot of neat tricks that we can do. And we're also going to talk about layer masks so that you're only grounded when you touch a object that says you're grounded. Alright, so let's go ahead and continue. So what's the first thing we want to do? How about we just make Tim move left and right? How would we go about that? So in 3D, Unity provides what's called a character controller. And basically it has a function called controller.move. And it allows you to pass through a vector 3 to move along whatever axis you specify. Well, in 2D we don't have a character controller. So we have to create one ourselves using rigid bodies. So first thing we have to do is add component rigid body 2D. And rigid body is how we enable physics in our engine, in our game. So basically what we need to do is we are going to move using velocity that's built into the rigid body physics system. And velocity is just the speed with direction of travel. Alright, really simple stuff. So what we're going to do here is go ahead, and you don't have to touch anything here. So we have a rigid body on our player. So let's go and create a new C# script and name it player. And basically, what do we want to do? We want to move our player left and right using velocity. So let's go ahead and look up how we can do that. Let's use the scripting reference. So Unity 3D rigid body 2D. And note that it's also, yeah, let me mention that, guys. Note that we used rigid body 2D and not rigid body. Whenever you're in 2D, you need to use a rigid body 2D. A rigid body component on a 2D sprite would not work. Okay? So yeah, make sure it's rigid body 2D. So let's go and look that up. So here you go, API rigid body 2D. And we have here all the different properties of it, and we have functions. And what we want to look for is, okay, so moves the rigid body to position. We have move position. And let's see if there's something better. What's in here? Rigid body 2D. Okay. I was hoping for, oh, here it is. Okay, velocity. Linear velocity of the rigid body. So that's what we want. We want to manipulate that. Okay, so it says description. The velocity is specified as a vector with components in the x and y. There is no z direction in 2D physics. The value is not usually set directly, but rather by forces. So the velocity can also gradually decay due to the effect of drag if this is enabled. Okay, So what we want to do is figure out how do we manually set the rigid body dot velocity. Click on this rigid body dot velocity here. It says see also. So basically, this is in 3D, but the same concept applies. Basically, you call your rigid body and you get the velocity of it, and then you assign it a position. How do you want to move? And look what they're doing. This is like for a jump function. You move 10 on the y-axis. What we want to do is call our velocity, and we want to move on the x-axis with whatever speed we set. So let's go ahead and try that. So basically, what we need to do is in void update, we need to call current velocity and assign it to new velocity. Just like we did with our positions, if we want to take our, how do you set a new position? Take the current position to a new position. And to do that, what we say is simple. Call our current velocity. How do we get our current velocity? We use rigid body 2D to get a hold of the rigid body component. And I'm actually going to go ahead and cache this, and you guys should too. Just like with the transform component, we don't need to look up every time we write rigid body 2D all the functions it has. So by creating a private handle, rigid body 2D, and then we can call it, my rigid body. Alright, by creating this handle, it's a little bit of a performance increase. It's not much, but it still is. Unity 4.x, whatever you guys are on right now, doesn't cache it properly, and assumably in Unity 5 they will cache it properly. So what we need to do here is just assign that rigid body to our rigid body component. Equals, you could say this dot rigid body 2D, or rigid body 2D. Same way we did with the transform. The this keyword is just specifying this script that this game object is attached to. Alright. Okay, and also guys, I picked up a new coding standard over the past year, and it's for private variables. I use an underscore, and it just allows me to distinct between public and private variables if my scripts were to get too long. That way I don't have to scroll back up. Alright, so it's just a preference. You don't have to follow it. If you do, good for you. Okay, so basically what we need to do is call our current velocity, which is stored in our rigid body. So you say my rigid body and get the velocity, and look what it says when you do that. Look at the tooltip here. It says, oh my gosh. So when I type, before I hit enter, it says get and set. Anytime you see that, that means that it's requiring you to assign a value. So you can get the rigid body velocity, and then I can also assign it. I can set the value. And we do that using a new vector 2. So remember, there's no z-axis in 2D, so we use a vector 2 instead of a vector 3. So we can only work along the x and y. And what we want to do now is say new vector 2, and then just like we did with transform.translate, instead we're using rigid body dot velocity. I want to move left and right. So I say vector 2 dot right. Okay? And what I can do is multiply that by some speed, and then for the y, I don't want to necessarily move on the y right now, so I'm just going to call my current y. My rigid body dot velocity dot y gets the current y. So now if I go ahead and save this, what's going to happen is I'm going to constantly move to the right. And it looks like I have an error here. Why do I have an error? My rigid body dot velocity equals new vector 2. It says float has some invalid arguments. Why? Alright, hold on. What if I just pass in a 1? Okay. For whatever reason, guys, it doesn't want you doing that. So, also, why did we just fall? Does anyone know why? Simple. So, our ground actually has no collider. So, check this out. Our grass sprites here don't have any colliders. So, what we could do is click on each of them, and we can add a box collider 2D. And that adds like this collider, and if you hold down shift, you'll get these handles that you can actually use to create colliders around where you want his feet to be. Now this can be lengthy because that means that every platform we create has to have a collider like this. Well, look at our ground. It's kind of long, right? And I really don't feel like creating all of these and manually resizing them. So I'm going to actually go and remove that. And we're going to use a tool called an edge collider. An edge collider basically allows you to run a line across multiple platforms and basically it acts as just a box collider. So if you hold down shift, you'll get these handles. See how it's green here? You get the handles. Basically what you'll do is you'll select it and you can drag it and position it where you'd like. So for instance, I want to take up the entire part of this texture. So I'm just going to grab it, put it right about there. And then I can do the same thing to the other side to bring it back down. Whoops, don't do that. And there you go. Now I have an edge collider along the grass that Tim can walk on. And you can actually do a lot of things with this. You can move it up, you can tilt it, and it's used basically in the 2D tutorial by Unity, the official ones. It lets you do a bunch of different things with it. You can actually map it to the design of your foreground. Alright, there we go. So we have our ground set, and you can also make that a trigger, but we're not because we want Tim to walk on it. So let's go ahead and test it out and see if he walks on it. Okay, so he didn't get stuck on it. Why? Well, let's figure it out. We have our collider for the ground, and that seems to be working fine. But what about our player? Our player has a rigid body which has gravity selected at a scale of 1, so it's causing us to go down. But what our Tim doesn't have is his own collision system. So we need to add a box collider 2D to Tim, and you'll see here that a box automatically gets generated around him. Now if we run the game, there you go. He stays still. And now we're obviously not moving to the right either. So, I don't know why. But regardless, look what our code would have done anyways. Our code is saying take the current velocity and assign it to 1 on the x and my rigid body.velocity, whatever the current y is. So we want to move our velocity based on user input, right? So let's go ahead and get the user input. Do you remember how you get the user input for left and right arrow keys or A and D keys? We use the GetAccessHorizontal. Alright, I'm going to assign that to a float value called move. And the reason why it's a float value, guys, because if you look in the scripting reference and if you've watched my first video, it returns a value between -1 if you hit the left key, +1 if you hit the right key. Okay, and 0 if you're not holding any of them. So to assign that, you take, remember it's a hierarchy structure, the input manager, then you have to do a get access. And the access you want is horizontal, and that will allow you to use the left and right arrow keys. So now we can replace this 1 with move, and that way, based off it's whatever it is, if it's left key, then I go to the negative, it's -1. If it's the right key, it's +1. So let's go ahead and test it out and see if it lets me move. Oh, and you know what? I don't think I ever attached the script. That's why it wasn't working before. Make sure you attach the script. Click on player here. Alright, and you should be able to move now based on user input, which I can, and it's very slow. So let's go ahead and fix that. How can you speed them up? You create a speed variable. So go ahead and do that. And you can make it public so you can see it in the inspector. And notice that with my syntax, I don't put an underscore on speed because it's a public variable. And basically I would say move multiplied by speed. And there you go. So now I can come in here in my editor. I'm just going to set the speed to 5 for now. Try that out. Okay. Alright, there we go. So now we're moving. And alright, yeah, so we're moving, and basically now what we need to do is make it so we can, and also if you notice, when you go to the right, you can move, but if you go to the left, you actually just move backwards. You don't face that way, so that's going to be a new problem we're going to have to face. Okay, so now that we have the movement, let's go ahead and do the animation. Let's go ahead and make it to where before moving, or yeah, before calculating the movement, let's actually play the animation we're supposed to play. So when we hit the right arrow key, let's play the animation. Alright, so to do that, we need to now go into Mechanism. So looking at our, open up your animator view, and you'll see here that we have our idle, our run, and our jump animations. What we need to do now is create logical transitions. So for instance, I'm going to show you guys how to use any state as well. Let's do idle first. When can I go from idle to run? If our player movement is, basically, we want to do it based on user input, right? So if this move value, which is between -1 and 1, and 0 if nothing is played, if it's greater than 0, then we want to move. Does that make sense? We want to start the animation. If it's less than maybe 0, then we don't want to play the animation. So let's go ahead and create that logic. So right-click idle, make transition, and click on run. And if you, and what we have to do now is also set a parameter. So we need to compare, in order to script this, we're going to have to basically make the parameter check for our move function. And we're going to go over how to do that. So click on parameters here and create a float. And this is going to be for speed. Alright, so if the speed of the player is greater than 0, that means we're moving. We need to play our animation. If it's less than 0, we stop playing. We go back to idle. So click on the transition itself, and you'll see here, exit time, which means it's valid. Change it to speed. If speed is greater than 0, then we switch to run. And here it is. Greater than 0, we run. Perfect. Now what we want to do is, when could we go back to idle? So you have to make transition from run to idle. And basically we have, when should we stop? When should we go back to idle? If exit time, or I'm sorry, if speed is less than 0. Let's try that. So if speed is less than 0, we go back to idle. So now what about for jumping? When can we jump? If I'm in idle pose, do we want Tim to jump? I'm going to go ahead and say yes. What if I'm running? If I'm running, can Tim jump? So I'm going to go ahead and say yes too. So create your idle, make transition to idle. And basically, you're going to say, and we actually need to create a new jump. In our code, how do we know when it's time to jump? We want to jump based on, we need to check. We need to check based on code. If, say, I hit the space key, it's time to jump. So how do we create checks in programming? We use what's called bools. So in order to create a condition for if I've clicked like the space bar, we need to create a new parameter of type bool. And it's going to check for a true or false value. So go ahead and name it jump. And we're basically, through code, we're going to say, if I hit the space bar, we're going to call into this parameter. So we click jump, and you can see here it's false, and then true, false, true. Keep it at false. So idle to jump, and you'll change the condition here. And you'll see here, what do we want to do? If jump equals true, then we go from idle to jump, right? So go ahead and play that. Idle, and there's jump. Okay? Let's go ahead, and now we have to go back to idle. So you right click, make transition from jump to idle. And when should we go from jump to idle? Sorry. Okay, basically we go back to idle when jump is false. Makes sense. Very simple logic there. Alright, and then we're going to do the same thing for run. So now let me stop you here. So ideally, if we want to do the same thing for run, we would just copy exactly what we did for idle, right? So this is where any state comes in. Let me go ahead and remove these one. I'm going to go ahead and remove these transitions by clicking on it and hit this minus button. And basically, I only have 3 states here. I have an idle state, a run state, and a jump state. Those are my animations. Whether I'm in idle or run, I can always jump, right? So that's what this any state is for. Any state says whatever the current state is can do whatever animation it's pointed to. So if I click on any state, make transition to jump, that means that whatever state my player is currently in, no matter what, he can transition to jump with simple logic. Click on it, make transition. Sorry, my screen here. Okay. Make transition. And basically, if jump equals true, then we go to jump. From any state. If I'm in run and jump equals true, I jump. If I'm in idle and jump equals true, then I jump. And then what you do have to do is click on jump, make transition, and you do have to transition them back manually to run or idle. So for run, you just say if jump equals false. If it's false, then we go to run. And same thing, if jump is false, we go to idle, whichever one we were in before. And you'll see how both those work. Alright, so now I have all my transitions working properly. Now what I need to do is go ahead and figure out how to script this stuff. So let's go ahead and talk about what we want to do first. So basically what I'm doing is, here's our move. Alright, so this moves the player based on user input, and our rigid body moves that too. Now maybe before moving him, let's go ahead and play the animation. So what we want to do is, play mechanism run animation. Alright, whenever move is greater than 0 or less than 0. So how can we do that? We need to look up in the scripting reference how to use mechanism. So here we go. Just go in scripting API mechanism. Let's check out the manual here. And you guys should read this page, the manual mechanism animation system. Just tells you a little bit about it. What's important to see here though is Bringing characters to life. This involves setting up animation clips as well as interactions between them and involves setup of state machines and blend trees, exposing animation parameters, and controlling animations from code. I'm going to go and just click that. Okay, animation parameters. We have vectors, int, float, and bool, which we just created. We created a speed jump. And look at this, it's actually giving us an example. It says parameters can be assigned values from a script using functions in the animator class. We have set float, set int, and set bool. I don't know what these do. So set float sets the value of a float parameter, and it has a name and then a value. Description, okay, so they don't really give you a code example, but it looked like they had code example here. So let's look at this. So here's an example of a script that modifies parameters based on user input. That sounds exactly like what we're doing. And right here off the back, look what they're doing here. This is a private handle. If you watched my Get Component video, you need to create a handle to access the animator component. Because remember, that stores your animations. So they're using protected. You don't have to use protected. You can keep it private. Don't worry about the protected for now. You can look it up if you're interested. So private animator. All right, that's their handle, and then they're assigning the handle to the component. So we should do that as well when we get to it. And then look what they're doing. They're just checking to see if the animator component exists, and then they're doing get current state. I don't know what that is. I also don't know what any of that is. Base layer dot run bt, don't know. Okay, so look at their jump one though. This is interesting. If input.get button fire one, which is that's the input for jump, then they're saying animator, which is their private, this is their handle, dot set bool, and then the parameter that they created jump, and then they're giving a value of true. So basically, you call onto the parameter and you set the value in script. And remember, we have conditions that say if that parameter is true, we jump. No way Mechanim scripting is that simple where it's one line of code. Incredible. Look at this example here, what we have set up. Float h equals input.getAccess horizontal. Pretend this is our move, float move. And then look at this, set event parameters based on user input. Animator.setFloat, because that's the parameter they set, and we're using a type, it's a parameter name of speed, and then you pass through some value here. I don't know what that value specifically does, but it's similar to what we want. So let's go and do that. So looking at the scripting reference, they're saying animator.setFloat. In order for me to set a float, I need to first create a handle to my animation component. So I gotta say private animator, and that gets a handle to the component, and then give it a reference name. So animator, I'm just gonna name it anim. All right, and then what I need to do is in start, I need to assign anim to the component. Then animator. And guys, if you're not following along with this part, I really recommend you watch my Get Component video number 8, and that will show you exactly what we're doing here. So anim equals get component animator. Now I can type underscore anim dot to set the float. So it says play Mechanim run animation here, and that's what we want to do. So the way we're going to do that is type underscore anim dot set float, and if I open up a tooltip, look what it says: int id float value, and it says 1 of 4, string name float value. The name I set for the speed for the parameter is speed, right? So speed, and then comma, and it's asking for a value. The value you pass in there is what's going to make that condition true. Because if we look at it, when does it become true? I go from idle to run when the condition says speed is greater than 0. When is speed ever greater than 0? When I hit the right arrow key or the left arrow key, or if that's going to be negative 1. So when I hit the right arrow key, it's greater than 0, right? Because it's a float value between -1 and 1. So basically what I'll do is I'll put in our move here and save it. And let's go and test it out. If I run my game here, right now I'm idle, and then there you go, I can move. Okay, so what do you notice though? Obviously, if I run, so look what happened. So I actually just lifted up off of the right arrow key, and it's still running. And I feel like that has to do because it's a float value, and it goes, remember, the input.getAccess goes from -1 to +1. It's float values, not just -1 int, +1 int. And then, of course, if I go to the left, that just doesn't work. And then, oh, actually, no, that's a different bug. Check this out. I'm not holding anything right now on my keyboard, and he's running, which means something's wrong with my logic. I think we're telling him to do that. So if I look here at my transitions, I'm saying if speed is greater than 0, I run. That's correct, right? And then I'm saying here, if speed is less than 0, then I go to idle. When is it ever less than 0 when I let go? It's not. So I need to say like 0.1. Because remember, it's -1 if I hit the left key, +1 if I hit the right key, 0 if I hit no key. So now if I try it, there you go. Now I can stop. And I can't run when I hit the left because remember, it's a negative value. And we're saying, our transition says if it's less than 0.1, which -1 is, then you play idle. So we're going to come up with a solution to that first, but or after. But what I want to show you guys is when you run, you might notice that your character after you stop, like after you lift up, still runs for like a half a second. We can fix that by changing the input. So getAccess returns a float value between -1 and 1. There's something called GetAccessRaw that says it's an int value between, if you hit the left key, it's -1. If you hit the right key, it's +1. There's no float values between 0 and 1. So go ahead and do that and save it. And now we'll look here and see what happens. Much better. Alright, it's more smooth. So I can move to the right. Let's go and make it so I can move to the left. Why does that happen? If I run right and I hit the left key, it doesn't work. If you look at Tim, look at how he's facing on the Y axis. He's facing this way and he runs, but if I hit the left key, it's idle. So we're going to have to fix that so we can play the right animation. But also, we should get it to where when he hits the left arrow key, he faces left. How do we do that? Because we don't have a run animation for going left. I only have the run right animation. Well, it's really simple. In 2D, you can mirror the object. So click on player, and in the transform component on the Y rotation, set it to 180. And now look at Tim. He's facing left. And he can move left. If you hit the left arrow key, he just drags, but he can run backwards or run to the right, animation plays. So we need to fix that. And the reason why that's happening, guys, is because, like I said, the input manager returns a negative value. And we're saying right here in our transition that if speed is less than 0.1, which is 0 or less, could be -1 as well, then we play the idle animation. So this is where a little bit of math comes in. We need to look at this, and we need to say, how can we make move only a positive number for both going left and right? Well, there's the math class, and you remember in math, the absolute value of a number? Absolute values can't be negative. So for instance, a -1, the absolute value of -1 is 1. So even if I'm going to the left, which is -1, we can take the absolute value of that and convert it to 1. So how do we do that? That's really simple. In your parameter here, you type mathf, and let's get the tooltip there. There's an absolute formula in the mathf class. So you type mathf.absolute, which is ABS, and what you do is it asks for a value. You're going to pass through move. And now, what will happen is regardless if I hit the left or right arrow key, I will play the correct animation, but if I run to the left, I don't face the left. But again, if I go to my player on the Y and I say 180, now I can run left, but if I run right, I need to flip him again. So basically, through code, we need to create a function that's going to allow me to flip Tim. And it's really simple. How can we know what direction we're facing? How can we check to check to see what direction we're facing? That's where bools come in. Let's create like a bool system that says, that checks for facing right. So by default, we want Tim to face right. So let's go ahead and fix this now. Basically, the pseudocode for this is, let's go and write some pseudocode. What do we want to do? We're going to have a bool that says facing right because we need to know if we're facing right or not. So let's go ahead and do that. So public bool, actually, no, you can make it private because I don't really need to see it in the inspector. So I'm going to go ahead and say private bool underscore facing right. I'm going to say equals true because at the start of the game I am facing right. So basically what's going to happen now is our pseudocode, what do I want to do? If facing right, so like if facing right is true, but move, which is your input, so you'd say like, and move is less than 0, that means that we're facing right and we're moving to the left, then what we need to do is say facing right equals false, and then we need to get the rotation of the game object. So how do you get the game object's rotation? Remember, game object is a transform, you want the what? The rotation of it, and then you want to change the y equals, 180 to flip him. 180 degrees to the left, 0 degrees to the right. Now you'd have to do the same thing. So you would say if facing right equals false and move is greater than 0, that means that you're facing left but you're moving to the right, then we need to flip them back. Facing right equals true, and then you need to call your transform.rotation.y and set that to 0. Alright, so you guys are going to go ahead and do that on your own. I'm not going to help you there. I'm going to go and pause the video though just to get it working on my end, and if you have problems with it you can ask questions on how we can go about that in the script. But it should be pretty self-explanatory. Just use pseudocode and fill in the dots. Note that you cannot implicitly convert a value to a new value. You can't just say transform.rotation.y equals 180. Do you remember how we set a new position? You take the current position and assign it to a new position. Okay? I'm going to go ahead and pause it here and go and fill that in so you guys can't watch me. Alright guys, so basically what I've done is I've done the rotations, and you can see here, if I hit right, I face right. If I hit left, I go left. And there we are, we're running. So next we're going to do the jump. And I just want you guys to know, if you're having problems with setting the rotation, rotations are handled using what's called quaternions. So if you want to know how do you change the rotation of an object, how do you assign a new rotation, what you would do is let's go to the scripting reference, and you would type in, even Google, here, how to set a rotation of a game object. Unity 3D. Let's see what shows up. How to set up a single axis rotation of a game object. Right, that's not what I wanted. Okay, so here, look at this. So they're saying rotation equals quaternion.identity. Identity, if you remember from my old video, just means no rotation. So let's look at the quaternion class. Quaternion, alright? Quaternions are used to represent rotations. So you can see here that we have quaternion, and they use what's called Euler angles. Returns the Euler angle representation of rotation. Euler angles are nothing to be afraid of. All they are is literally the axes of which rotations happen. So for instance, Euler angle of the player here, we have an x-axis, a y-axis, and a z-axis. The Euler is the rotation along those axes. So for instance, it's just how I'm rotating. So right now the Euler angle, this is the Euler angle of my x, the Euler angle of my z, and the Euler angle of my, y and z. Euler angles are just the rotation values that are on the x, y, and z axis. So how would I make the Euler angle 30 degrees on the x? There you go, 30. How would I make it 50 degrees on the z? 50. Alright? The Euler angle is just the rotation that's happening on that current axis. Nothing to be afraid of. So what you need to do is basically you take the current Euler angle, which is transform.rotation, and then you assign it to a new one by saying quaternion, look at this, returns a rotation that rotates z degrees around the z-axis, x degrees around the x-axis, and y degrees around the y-axis in that order. Euler. And here, look at this. They're saying rotation, okay, so you don't have to do public quaternion rotation, but you can say public transform, or I'm sorry, you don't have to do any of that. You just have to call your current rotation. Transform.rotation equals quaternion.Euler, and then look at that. They're doing a 30-degree rotation on the y. You would do a 180. All right, really simple stuff. Just use the scripting reference if you have problems. Just know that quaternions are how rotations are handled. The Euler is how you set individual axes. All right, so let's go back. So here we go. We have our code working where I'm moving right as well as left. And now what we want to do is let's go ahead and create the jump logic. When should I jump? Whenever this parameter jump is true, right? So let's go ahead and create that. Let's go ahead and do it right under update, I suppose. And let's go ahead and just create the functionality for jumping. Basically, I want to do it where if I hit the space key, right? So pseudocode. If space key is pressed, then then mechanism jump equals true. All right, we have to access the mechanism component. Okay, so if space key is pressed, mechanism jump equals true. Let's fill it in. If, and remember, how do we get the space key? Input dot get key down, and then remember your key code. All right, this should not be new to anyone. So if input dot get key down key code dot space, what do we want to do? We need to call the mechanism jump. So how do we? Before we did set float. So we saw in the scripting example, you do anim dot set bool, and then look at the parameters. String name and the value. The name is jump, and the value is true or false. True. So when I hit the if input.get key down keycode.space, the bool is true. Let's go and just save that and test it out. Let's go and run the game. Okay, there we go. So he's jumping, but he's constantly jumping. Why? Because we've never actually said that, we never told it to stop. We need to check it for like a grounded function. When should it stop jumping? When should it go back to idle? When he touches the ground, right? So also we have another problem. He actually doesn't move anywhere. So maybe before setting the bool to true, or after setting it to true, let's go and move him up a little. So how do we move him up? Remember, you call your rigid body dot velocity, assign it to a new vector 2. We want the x to stay whatever it currently is. So remember the hierarchy structure, you call the rigid body dot velocity on the x, and whatever the current value of x is will be placed there. And then for the y, let's go and move him up like let's go and move him up 10. Go and save it and test it out. And remember, we have gravity applied to our rigid body, so he should fall. So he does. And there you go. But he's constantly jumping still, so we need to fix that. And actually, I'm going to go and increase the gravity on him. Make it like 2.6. Alright, that works much better. So change that back to 2.6. So now what we need to do is basically we need to create logic for if he's grounded. How can we check if he's grounded? In 3D, on the character controller, there's a function called isGrounded. Well, we don't have that. So what we're going to do basically is we're going to cast a ray from his position in the downward position. And if that ray were to intersect something, then he can, then he can jump again. We'll set like a bool. How do we know when he can jump or not? So we need to create a check that even says if he can jump or not. So how do we know if he can jump? Just off of the space key, right? Well, we need more than that. Let's go and create a bool that says he can jump. So basically, you're going to create a private bool, can jump. Alright, and by default, well, you can just leave it like that. Okay, cool. So when do we want to jump? So if input.getKeyDown, keycode.space, and can jump equals true, right? And when's it going to go true? It's going to go true as long as he's touching the ground. Once he's not touching the ground, we play the animation, we move him up, and then what do we say? Can jump equals false. Makes sense. So now we need to find a way to set can jump equals to true. So how are we going to do that? We're going to do that through 2D raycasting. First thing first is I need to figure out how to do that. I know that raycasting uses the physics system. If you watched my previous tutorial on raycasting, so let's figure out how they do it. So physics, raycasting, 2D. Alright, here you go. Physics 2D.raycast. Okay, raycast hit, the cast results return, so it's just like hit info, raycast hit, hit info. They use raycast hit 2D. Let's see, description. Creates a ray against colliders in the scene. A raycast is like a laser beam that is fired from point in space. Okay? Let's go and look at their example here. So in 2D it's a little different. Look what they do. They take raycast hit 2D, which I would name hit info, and they assign it to the raycast. That's a little different than how we used to do it with an if statement. So this is how it's done in 2D. So I'm going to go and just copy that. Raycast hit 2D hit equals physics2d.raycast, position, starting position, and then direction, I guess that is. Let's go ahead and try that. So you come down here and you create your raycast hit variable. Raycast hit 2D, I'm going to name mine hit info. And then I assign that to the, what was it? Physics2d.raycast equals physics2d. Alright, there we go. And look what it says, origin, direction. The origin is going to be my position, and the direction is going to be down, because remember, we want that ray to go to our feet to check and see if we are grounded. So I'm going to go and say vector2.down. And I should be able to just save that. And then to make it work, what you do is you want to check to see if you hit something. So to do that, it's called null checking. You create an if statement that says if hit info, is not equal to null, meaning that we hit something, then what do you want to do? Let's just debug a message that says hit. Alright, go ahead and test it out. And it looks like I have an error. Lots of errors. Does not contain, oh, okay, there is no down definition, that's why. What does that mean? Up? Okay, I can do up. And then put a negative next to up, and that will cast in the opposite direction. No, got another one. Okay, now we're good. Alright, let's go and test that out. Okay, so it says I'm hit, but when did that happen? Let's go and move Tim up in the air and see when that hit gets called. And actually, you know what? Right when hit occurs, I'm going to go and stop the game so I know where that line is casting. I'm going to say time.timescale equals 0 to freeze the game. Alright, let's go and test it out. Okay, wow, look at that. Somehow my ray is hitting the ground from here. So this is a problem with 2D raycasting. For whatever reason, if this was a 3D game, this would work probably perfectly. But with 2D, they don't recommend you actually use a raycast. You use part of raycasting, but it's something called, it's a little different than that. So let's go to Physics 2D here, and there is something called, so raycast isn't going to work out for this situation. I don't know why, and I just don't really know why. I just don't know why it's not working, nor is it relevant to why anything I'm going to do. So it's just not working. So there's a different thing that we can use in 2D called a line cast. And if you go down here, cast a line against collides in the scene. A line cast is almost the exact same thing as a raycast. It technically is. If you click on it, it has a start and an end point. Raycast hit 2D, the cast result returned. So we still use the same syntax, but using a line cast. A line cast is an imaginary line between 2 points in world space. Any object making contact with the beam can be detected. So it's just like a raycast. For whatever reason though, raycast doesn't work. A line cast is perfect for interactions, checking to see if you're touching an object. It's also perfect for checking if you're grounded. You can cast a line from your feet. So look and see how this works. It says start, the start position of the line in world space, and end, the end point of the line in world space. So instead of saying the length of the line like we did in raycast, you actually create an object that says the start position and end position. So let's go and look at the syntax for it. So hit info equals physics2d, physics2d.line cast, and you'll see here it says vector2 start and vector2 end. So it's looking for positions. So let's go and say my transform.position, and then I need to pass through a vector2 end. Well, I don't really know where the end is, but what I can do is I can say my start, and then what I can do is I can actually create a game object that will act as the end position. And that's the benefit of a line. So I'm actually going to do that for the starting position too. Let's go and do this. So what you're going to do, guys, is in Unity, we have our player here. Let's go and create a few game objects. Create 2 empty game objects. And go ahead and name that one start pose. And create a new one named end pose. Alright, and you're going to drag these into the player so that they are children objects of the player. So we have end pose. Okay, so now we have what here? We have two basically transform objects that have nothing attached to them. Go ahead and set their positions to 0 so that they get on the player. And what we're going to do now is we're going to draw a line cast allows you to set where you want them to be. Remember, it asks for a position, and the position is stored in the transform component. So what we can do is we can say start pose equals 0, 0, 0, and the end pose is going to be maybe down to, we want it down to his feet, right? So down to like right there maybe. And make sure it's, let's see. Okay, right there should be good. I have mine at like negative 0.6591. Okay, so just position that one down to his feet. So now how do we make this work? Well, how do we access these transform components? We can create variables to store them in. So basically what we're going to do is create public variables. Public transform, because remember, it's like almost creating a prefab slot. Public transform, we're going to have start pose, and then public transform end pose. And this is just the starting pose of the line, the end pose of the line. Remember, it asks for a position variable. So how do we access the start position and end position of those game objects? We type start pose, which gets the transform component, and then dot position. So in the inspector, you save this script, and you can assign, clicking on the player, it's assigning, you can ask for, and I have more errors, unexpected symbol if. Oh, my bad. It doesn't like that. This is incomplete. Delete that for now. Okay. Okay, so look, the player here has start pose, end pose, and it's asking for transforms, which this is. So you drag it in there, end pose, drag it in there. So now I can cast a line cast to those 2 points and check for collisions. So let's go ahead and do that. So remember, we do raycast hit 2D, and then give it a name. We're going to access information about what we hit through hit info, and assign it to physics2d.linecast. And this parameter asks for a start position. The start position is that position game object, start pose. So I need to access the start pose game object, which is its transform, and then get the position. And then comma, vector2 end. What's the end position? End pose dot position. And then you do the same thing. Check to see if it hit anything. So you would say if hit info not equals null, meaning that it exists, something we hit exists, then what do you want to do? We want to say, let's go in debug.log hit, and then let's also stop the game so we know where we stop. Okay. Alright, now let's test it out. Alright, so we still stopped up there. Why? It's very annoying. Hold on. I wonder if my end pose is hitting my box collider. Or, you know what? There should be an option to draw gizmos. Let me see if we can do that. Okay, let's make it so we can actually see our line. How about that? So, if you remember from the raycasting video, there's a function called debug.drawLine. Let's go and do that. .drawLine, and start position is start pose dot position, and vector3 end is going to be end pose dot position. Let's find out where that line is. Okay, so check this out. You see the line here in the scene view, it looks like? That line is hitting our own collider. So it looks like the end pose needs to be a little longer. Let's go and do that. Now try it out. And if you actually select on gizmos, you can actually see it in the scene view, in the game view. And it looks like it might still be. Alright, now I'm lost. I don't know. Why is that happening? Okay, so it's not the end pose anymore. What is causing it to stop? Oh, you know what, guys? I think it's that line might be hitting some of our other, maybe it's hitting our background or something. I have no idea. So this is where layer masks come in. I only want the player to be able to jump and land on ground objects, right? Something like platformable objects that say I can jump again, okay? Because we can jump off of anything that we can land on. So this is where layers come in, and I think that's what's happening here is we need to assign a layer. Basically, our raycast is hitting whatever it wants. We can tell the raycast or the line cast to only grab objects based on a certain layer, and the layer is based on this property here in the inspector where it says layer default. And what you do is layer default here, and we're gonna go and create a layer. Go to add layer, and you see where it says user layer 8. Go ahead and create a ground layer. Alright, and what we're going to do here is go ahead and select all of your ground objects, which include the grass, as well as any platform you created or your steps, and go ahead and set the layer in the inspector to ground. Now what we need to do is figure out how we can cast the line to only hit that. So if we look at what physics2d.linecast asks for, it's saying physics2d.linecast, and look at the parameters for it. It says vector2 start position, end position, and then layer mask. And the layer mask means that it only hits based on that layer. And it's asking for an int value. So we're going to go over how to do that. So let's go and put our transform back in. So we have start pose, dot position, end pose, dot position. And now we need to assign a layer mask. We only want the ray to hit ground layers. So how do we do that? It wants us to pass in an int value here, right? Well, first, let's go ahead and do this. Let's assign a layer mask to the inspector so we can just easily assign a layer mask to the objects that have a layer. What you would do is go ahead and create a public variable and name it of type layer mask, and go ahead and say, my layer, or your ground layer even here, ground layer. Okay, so there we go, ground layer. Go save that and go to the inspector, and look what happens on the player on all the game objects here. Actually, the player. I'm sorry. So what we're gonna do here is on the player now is, God dang it, more errors. Sorry, guys. Ugh. Why is it not like this? Oh, I'm missing a semicolon. Jeez. Okay. What was I gonna say? Okay, so look at the ground layer now. We have this in the spec. It says nothing, right? Assign it to ground. And what that means is now we have a layer mask set to ground, and we can tell our raycast to check for that ground layer. So if an object has a layer of ground, it hits it, but if it doesn't, it ignores it. So go ahead and open up your script here, and let's go ahead and add in our parameter. It says, whoops, end position parameter, and see how it says int layer mask? I actually don't know the int value. So what you can do is type ground layer, and then dot, and put the value. Whatever value is assigned to ground layer is the layer that's going to be used, and it will convert it to an int for you. And if we save it, this might actually work now. Wonderful. And that did not work. Let me see, player, ground layer. My gosh. Let me see. The animator component. Moves like get key down in space and can jump equals true. Where did we go wrong? Hey guys, sorry. I know why that was happening. Basically, hit info is never null because it's always going to hit something. I need to say, instead of just hit info not equal null, you actually have to say hitinfo.collider because that's what we're checking for. We're checking for collision. So hitinfo.collider gives you access to game objects you hit. So hitinfo.collider not equal null, and then now this will work properly. Debug.log, let's go ahead and hit, and then let's also freeze the game. Wow, gosh, I'm just awful today. Sorry, guys. Okay, there we go. Let's go ahead and save it and test it out. And I can't move. Oh, I can move. Alright, so why can I move now? Oh, hold on. My connection's broke. 1 second. Hold on. Start pose. End pose. Okay. Now it should work. Let's try it out. And there you go. Can't move. Perfect. Alright, so look at that. So we're grounded. So now what we need to do is, here, let's go ahead and make it so I can actually move now. So instead of setting the game to 0, what do we want to do actually? So if we hit something that has a ground layer, then we're going to get a debug.log message that says hit. Alright, and I can jump, and actually I can't jump because it's false. What we need to do is, let me see here. Okay, so basically we can only jump when can jump equals true. When should can jump equals true? Whenever we're touching a ground layer collider, right? So let's go ahead and say can jump here. equals true. And then what do we want to do? We need to stop the animation. Because remember, if we're true, if we transition to the animation when it's true. So we need to say, we need to take the animation by saying anim.setBool, and the animation we want to change is jump. And when we're grounded, should we be in the jump animation? No, so we say false. And this should function properly for us. Go and test it out. There you go. I can jump. Alright, and I can rotate around my scene a little. We're going to fix that too. Alright, here we go. So I can run left, run right, switch face. If I touch something that has a ground collision, ground layer, then I can jump again. I can't double jump. And that's actually happening because of our collider. So what we need to do is actually lower that if we don't want that to happen. So I'm going to take the end pose here. Just going to move it up a little bit. It's low too far down. And let's look at it. Alright, and that works really well. Alright, good stuff. Alright, so why is that happening? When I jump, if I rib cage the stairs here, why does that happen? I fall and I can twist and do all sorts of things. And I can even rotate in the midair. That's because our angle is getting affected when I rib cage it, or if my feet hit it or something like that. My collider is interacting with it. So my box collider is interacting with it, with the stairs box collider, as well as the edge collider on the floor. To fix this, it's really simple. Click on your player, and you see right here where it says rigid body fixed angle. Go and check that, and that will add rotation restraints to the game object. So now I can jump on each stair, and I can jump off. Alrighty. Alright guys, I apologize for a lot of errors. I really didn't want to edit a lot out because I feel like maybe it's good for you guys to see how I can come up and solve those problems. Yeah, no, so this is our character controller that we're going to be using for the rest of this game. You can move left, right, you can jump. We created transitions for not being able to jump. And let me find out why when I just jump that happens. Because I'm still in idle, so 1 second. If input that get key down, key code dot space, and can jump equals true. Anim.setBool, true. So then we set can jump equal to false. Seems like the bool isn't really getting true there. Can jump, we'll say equals true from default. Let's see if that fixes it. It's weird, it's requiring 2 taps. But if I'm here, it doesn't. I think it has something to do with my line. I think what's happening is it's hitting this layer as well as the collider. Let me see here. Why is that happening? Why is nothing working today? Alright, let's take a look here. Let's see, if I hit the space key, if input.get key down space key and can jump equals true, I take the jump bool, set to true. That plays the animation. I change my velocity to that. Set the bool to false. Can jump equals true as long as we hit something. Not equal null, meaning we hit something with a ground layer. Then we set the bool jump to false. Let's try putting can jump after it maybe. I don't really know if that's going to affect it. See if it transitions. Alright, so when I hit space, that bool isn't coming true. Why? And can jump equals true. Alright, so I need to see the value of can jump in the inspector, but I have it private. So what can I do? Instead of making it public, check this out, guys. There's a method in Unity called square brackets serialize field. And if you put this over a private variable, it will allow you to see that variable in the inspector as well as change it. So now if I click on my player, because I serialized it, I can now see can jump. So let's go ahead, maybe it has something to do with where Tim is positioned to. Let's go and move him down maybe. Alright, so there we go. Let's go and run it. Alright, so my bool says can jump equals true. Alright, it's staying true. But if I double jump, then it goes false. So that should not be happening. So let's go and debug that. Alright, let's see here. If input to get key down, key code dot space, and can jump equals true, play the animation. Let's do this. Play the animation, can jump equals false, and then we move our player. Let's see what that does. And still nothing. Player, the bool says I can jump. Oh, also guys, just make sure for your stairs, make sure you do add the ground layer. Okay, so if I jump, if I double jump, it goes true. I have no idea why that's happening. It's very annoying. Oh, but if I'm running and jumping, nope. If I run off this and jump, it works. Hold on. Let's go and play frame by frame. Okay. And then I jump. I honestly, guys, have no idea why that's happening. Kiko.space and can jump. Yeah, I'm just gonna go and retype all that. Something's wrong with it. Here, let's do. You know, it could be the logic order maybe. Let's see. Raycast can jump equals true if I'm grounded. Let's put it underneath. Let's see. So if input dot get key down. So if I hit the space key. And can jump equals true. Then what do I want to do? I want to set the animation. I want to play the animation. So anim.setBool. It's going to be jump. Then the value is going to be true. And after that's true, I need to set false. Although no, I don't want to set it false. Set it false in there. Oh, I don't even know if I was setting it false. Can jump needs to be set false, so I can't double jump. And then it's going to say my rigid body dot velocity equals new vector 2. I'm going to get the x. Say 10 for the y. Try it out. Okay, now it's working. There we go. Okay, I don't know why that mattered, but yeah, no, if you have that same problem, then go ahead, do that. Alright guys, this is definitely a long video, but I hope you guys learned a lot. I hope there's a lot of interactive things going on for you. Hope I didn't just spoon feed you. But basically, use the scripting reference. If you had trouble with the quaternions, comment below. I'll try and answer your questions. Just know that mechanism animation, this is how it works. This is what it is. It's very simple to use. If you want to access a parameter, you just say animator to get the animator, set bool, set float the parameter, and then you have to give it a value to compare to. If you don't understand what we're doing here, just watch the video again. I'll try and explain it as best as I can in the comments. But thanks for watching, and on the next video we'll go over creating moving platforms. Thanks a lot, guys. Bye.